All right, so, and again, by drawing that, you know if it's a z-score or an area. Draw them, make sure you label them, and it will help. You'll know which one is z is negative and which one is positive depending upon where you are on that curve. Okay, so now that we had a crash last time, I'm coming from the notes here, and this is procedure for finding the values, but you guys already know that. You know you're going to sketch. You're going to sketch the curve. You know that. Okay? And as far as I'm concerned, if you want to use table, you can use the table. You can also use the TI 83, 84 calculator to find either and or your areas and or your Z's. And last time we went over going between the two, and if you're finding area, what am I looking up in my calculator? What's the, let's pull up the calculator just as a reminder. So, so I'm going to go to second distribution again. And I want to go to normal CDF if I am what? Finding a area. Finding an area. I'm going to put the low limit of the Z to the upper limit of the Z. So this is going to be lower Z, comma, upper Z. And it's going to give me back the area. If I know the z-score, if I know the area and I'm going to the z-score, this is where I'm going to use inverse norm, and we're going to be punching in the area. The area that you punch in, though, has to be from left to right. And it must start at the very lowest level, meaning with negative that negative 9999999. So that's what area you're going to be punching in, and it's going to give you the z-score. Okay? Remembering that, of course, the z-score can be negative if it's at below the 50th percentile. And I think we even did some percentile problems when we worked Wednesday. Okay? The next part of this is we have to go back and revisit that. Is it considered to be within 2 standard deviations or not? And it gives you a formula here that x is equal to mu plus z times standard deviation. I would not remember that formula. Instead, I would just remember z is equal to x minus mu divided by the standard deviation. It's the same thing, just algebraically manipulated. So you can just know the one. That's how I do it. I know the one, and then I just solve for whichever I'm looking for. So if I was going between 2 standard deviations, z would be first time negative 2, and I could find out my x value. And then I would plug in a 2, a positive 2 for z, for the positive part of that 2 standard deviations. So that would be within here. And again, we use that as what we consider to be usual. That's the same we've done before. Within 2 standard deviations from the norm is what percentage? 95%. 3 standard deviations is what? 99.7. So 2 standard deviations away from the mean, again, are 95%. Okay. All right. So the next page of our notes that didn't come through, oh, look, it did, was there. It was just a blank page. Huh. Saves me writing, doesn't it? So here is a problem that we put up that I've given you for an example. When designing aircraft cabins, what ceiling height will allow 95% of men to stand without bumping their heads? Men's heights are normally distributed with a mean of 69.5 inches and a standard deviation of 2.4. We're going to put them in a calculator. Well, I think it's better, but you have to be able to sketch that to still know what all this means, right? Okay, so the first thing you're going to do is draw your curve. Sketch what it's giving you. That also helps you know, did they give me area or did they give me a z-score? And what am I looking for? Okay? Always the first step. And a lot of times I put both my normalized scores, meaning my z's, standard deviation, 0, 1, 2, 3, and I put what it tells me in the problem, so it helps me remember and keep things in context. So z at 0 is the same thing of mu, and mu here is 69.5. So again, I'm going to go ahead and put my z-scores, my normalized scores, and I'm going to take my standard, my mean, and I'm going to add 2.4 inches. So when I add 2.4 inches to 69.5, I end up with 71.9. Let's put that in a different color so it reminds us which is which. 71.9. If I go again, just so that I have that in my head where things are located, I'm going to add 2.4 again, and I'm going to get 74.3. I'm sorry? 74.3, correct? Okay, and then again, I can add 2.4 to be way out there to 3 standard deviations, and when I do that, I'm going to end up with 76.7. So I have a real good idea of what's going on here. Can I go ahead and subtract at least for 1 so we know? If I subtract 2.4, I end up with 67.1, and I could continue to subtract and get all those numbers as I wanted to. Okay? So all I did was label. I drew and I labeled. Now I'm going to decide, what did they give me? What do they want to know? 95% of men stand without bumping their heads. 95%, is that an area or is that a z-score? Area, and every time and any time it says percent, you know that's an area. No doubt about it. So when I think about 95%, would these people all down here be able to stand? All at the left-hand side, so I know I want to come all the way to the left-hand side. And then I'm going to shade until I get to 95%. So I don't know exactly where that 95%, I'm just going to guess. Okay? But the key is that I'm shading from all the way down. So it gives me a sense. And of course, 95%, when I change it to a decimal number, is 0.9500, correct? So 0.9500 is my area. It is my area. Two ways that I can do this. When I pull up my calculator, we are looking for the z-score. No. Right, what it says, though, that's a good question. When designing aircraft cabins, what ceiling height will allow 95% of men to stand without bumping their heads? So I'm really finding what? The ceiling height. So really what I'm finding is ceiling height. So my ceiling height is going to be in what? Inches. So I can find the z-score associated with 95% and then convert that to my x. We'll do that way, and then we'll do it another way. No, because what is 95%? 95% is the area, and I just said 95%, and if I put it in a decimal form, it's 0.95, and I put 00 on there. Do I have to? No, but 0.95. I usually do that. You can use just 0.95, but then all of a sudden, if you take your eyes away from this and you're on your calculator and you've got 0.95, that's much easier to confuse to a z-score because a z-score is 2 decimals. So I try to consistently, when I'm writing an area, I try to consistently do that area to 4 decimal points, because that would be another way that you're going to self-check. That's going to be, does it make any difference between the numbers? Absolutely not. But it just helps me remember that's an area I'm dealing with, not a z-score. Because I have to know exactly where that's going to be. So is that where it's going to be? Is it going to be 2? 2 standard deviations away? We don't know yet. All I did was draw it. I don't really know exactly where it's going to fall. I just sketched. I don't know exactly where it's going to fall. That's what we're going to find out. So this is where I'm what? I've got area, and I've got to find my z-score. So I'm going to use inverse norm. I'm going to use inverse norm. What is my area? 0.95, and you can put 0.95 or 0.9500, either way, doesn't matter. For right now, because we're going for z-score, which is the normalized scores, I'm going to leave mu at 0, and I'm going to have my standard deviation being 1. Okay, and I'm going to go ahead and say paste that, and I'm going to find that my z-score, my normalized score, is 1.6448. Mm-hmm. Okay, hang on. I'm trying to figure out how I can get this to swoop over. Certainly, there we go. I didn't want to help. Okay, so the question was, why am I putting these as 0, 1, 2, 3 when I know what my standard deviation is? I know that both of these mean the same thing. 71.9 inches would be normalized to be a z-score of 1. A z-score of 2 is when my heights are 74.3. And if you plug these in to this formula, whoops, here we go. Z is equal to, what is that one? X minus mu divided by the standard deviation. If you put in 71.9 minus mu of 69.5 and divided that by 2.4, guess what you're going to get? So that's how I'm normalizing my scores. Remember, normalizing scores helps me compare an SAT score to the DPST scores that were ranged from 1 to 4. Totally different scale, but by normalizing them, I can talk about them and compare them. Otherwise, how could I compare a score of 3 to an SAT score of 1150?
So whenever you do something like that, you're going to always, even though you're given the standard deviation, you're going to always put it in as 1 to have like that common ground.
Well, yes, we can do it that way, because sometimes I could ask for a z-score.
Okay, well, and when you do the inverse norm, I should say, you want to keep it as...
Well, we're going to do it 2 ways. We're going to do it 2 ways. The first time I'm going to do it, I'm going to make you work a little bit because I want you to see the difference, because I know those questions are going, what's going on, right? What I got here was because I left it at 0 and 1, what I got was my z-score at 95%. So that happens to be at 1.6448. I sketched it wrong, didn't I? Because it should be between 1 and 2, and I went too far. I don't know if I can erase some, so let's see if we can. Oh, I can, but I'm erasing everything, but that's okay. So now I can make it a more realistic drawing because I know what my z-score is. So this is going to be 1.6. Should I leave it at 4 or go up to 5 when I round? Leave it at 4, 1.64. But do I know the height of the cabin yet? No, but I can use my formula to find the height of the cabin for 95%. My z-score that I found was 1.64, right? Is equal to x. Well, x is what I want to find. I want to know what that height is. So I'm going to put x. I'm going to subtract mu, which is 69.5, and I'm going to divide by the standard deviation of 2.4. When you get an answer of 1.65, that should tell you that is not the inches, right? My finger wouldn't fit through there and stand up, right? Okay? So keep thinking about it in the context of the problem so you can keep these numbers straight. So how am I going to solve this? I'm going to multiply both sides. Here comes our algebra. We're going to multiply by 2.4 on both sides of that equation. When I multiply by 2.4, the beautiful thing, of course, is that 2.4 and 2.4 cancels. Somebody's going to tell me what the answer is to 2.4 times 1.64. 3.94 is equal to, since those canceled, it's just equal to x minus 69.5. So then I'm just going to use my algebra skills and add 69.5 to both sides. You remember this? Good. It's funny you remember it.
No, it's only because I haven't used it in a while.
I know. We never let you forget anything in math, though, right? Okay, so I'm going to end up with 73.44. Yes, Jackie.
But for the inverse one, we could have just put in the 69.5 for mu and the 2.4, and we'll give you that.
That's where we're going next. Yes. But I want to make sure everybody understands C-scores, see where it fits, et cetera, et cetera. So does this number, does this make sense based upon my curve that I drew? When I found out my 1.64, I knew it had to be between 71.9 and 74.3 inches. When I went through the calculation, I found that that height is 73.44. Yeah, that makes sense. It makes sense. I can put it on that curve. I can draw it. I can see it. Okay? I'm not going to grade that your drawing is on scale. I can't put them on scale. My drawing sucks. Okay? But you should be able to sketch it out so that it makes sense to you. You know, if I was sketching this and I said 95%, and if I put 95% here, would that even make sense? No. I would have to at least know that I'm well over the 50% mark. George? You didn't round. You didn't round for the Z when you plugged in the Z. You should always round your Z's to 2 decimals. Okay? And now we're going to do this the other way in our calculator, and our calculator is not going to round. Okay? And because it doesn't round, that's where we know we're going to get a little bit of variance between what we would get when we round and do the calculation by hand, or now when I say the calculator, just give me the answer. Okay, so I expect to see that on the test. I expect that that's going to happen. So let's go back to your calculator there. I'm going to do the exact same thing now. I'm going to go to second distribution. I'm going to cursor down to inverse norm. Those of you with an 83, you're going to have to put commas again. Okay, inverse norm and enter. My area is 0.9500. That doesn't change. Those with an 83, you're going to put comma. The rest of us are going to cursor down to mu. And this is a non-standard. That means I'm going to be using the actual scores. What is mu? 69.5. And my standard deviation, according to my actual scores, is 2.4. I'm going to cursor down. You guys are going to close your parentheses and hit enter. And I got 73.447. Wow. By hand, we got really the same thing if we round it. So I think it must have rounded some, George, for a little more than where you rounded. Okay. So, yeah, either way is fine. But I'd like you to see, I'd like you to sketch it out, compare that it should be between 1 and 2 standard deviations.
A little bit confused because now we put the standard deviation. Before we did it. So I'm kind of like...
Okay. So the first time we did it, we got standardized. standardized score of z-score because we put in 0 and 1. And we sketched it out, and then we found our x value by calculation. The other way that I can do it is actually go in and put the non-standard. I'm not going to use 0 and 1. I'm going to use the actual 69.5 and the actual standard
So
deviation.
with this one here, basically with all of these, there's different ways you can figure it out. So if I
Both
was
times.
to just figure out, I can just do the non-standard way and get the. I don't know
Absolutely.
the standard way.
Absolutely.
Oh.
But see, I want you to see it. I want you to see where it lays on that graph. I want you to see on that table. I want you to see on that curve. Because that understanding is really necessary. Okay? You're going to practice, don't worry. Here you go.
Kind of a way of checking yourself, too.
It is a way of checking yourself,
Once you know
Donald,
that
yes.
First 1.64, then you know that it's going to be in between 71.9 and 74.3. So if you find
Oh, I
something
see.
that's not in between those two, then you know that
You
you're
messed
not
up somewhere.
doing the right thing. Something
Makes
that has
Okay.
got confused somewhere along the way.
Exactly, exactly. So as you're going through them, I mean, when I had to learn all this years and years and years and years ago, we didn't have the TI 8384. We did everything by tables, okay? So we did that. We did those calculations every time. So the calculator is a great tool, but it can also be a hindrance if you're just punching buttons, because if you don't understand what you're punching in and what you're getting out, it's not going to be any help to you at all. Okay, so find the probability of an IQ score less than 85, and these are the good old standard, the mean is being 100 and the standard deviation of being 15. You guys go ahead, do that one, and number 14 of an IQ greater than 70. Okay? All right. So, again, we're going to start drawing. Let's do some identifying what we have. Probability. What's probability? Area. Probability is area. So, I already know that really what I'm finding is area under the curve. I know that because it says find the probability. Okay? So anything that you can pick out that gives you hints of what you're looking for and what you got, look at it. This 85 is the actual score. Is that score standardized? No, it's a non-standard score. A standardized score is a z-score, typically between -3 and +3. So it is a non-standard score, 85. So we're going to draw, this is number 13. We're going to draw our curve now because we have some idea of what we've got going. Right in the center, that's my mean. What's my mean? 100. My standard deviation, it told me, is 15. So if I'm going to go to the positive direction, this is going to be 115, 130, 140. If I'm going to go in the negative direction, this is going to be 85 and 55, right? All right, so that's my curve. These are non-standard scores. I can superimpose the standardized scores over top of that because I can write that this is mu is 0 when I standardize it. This is 1, 2, and 3. -1, -2, and -3. Those are my standard scores. Okay? So going back to what it wants, I'm finding the probability, which really means area under the curve, of an IQ score less than 85. Well, what's nice is that's a standardized score. So 85, where am I going to shade from 85? Left or right? Left, because I want to know less. I want to know less. Okay? We happen to know 85 standardized is a z-score of -1. But it could have said 87. It could have said 78. Okay? But then I could convert if I needed to. Okay? So now that I have my scores on my calculator, since I'm looking for area, I'm going to go to second distribution, and I'm going to go to number 2, the normal curve. When I press enter, here I have choices again. Here I have choices again. When I enter that, I'm going to enter the lowest z, left-hand z, all the way up to the upper limit z. Well, my lower limit is way down here to -infinity, correct? And I could use what my calculator brings up of -1 times 10 to the 99, sure. Okay? Or I said if you don't want to deal with that scientific notation, you can put negative. No, it won't take that negative on my keyboard. I have to use this negative. 9999999. Okay, so that's down here in -infinity, right? Because I can see that from my drawing. That's my low end. And I'm going to go up to, and I have a choice now. I can either say up to 85, or I can say up to -1. Either one, they're the same thing. 85 is normalized to be -1. So we can go to upper, and let's put 85. Let's put the actual non-standard score in. But when I do that, when I cursor down, I have to change mu, because if I'm using the non-standard, my mu is 100. Correct. It's clicking. You got it. See, I said practice. I'm telling you, practice is the key. And my standard deviation, can't leave it at 1 because I'm using non-standard, so it's going to be 15. Okay? I'm going to cursor down. Go ahead, enter. And I'm going to find that to be 0.158655. What is that? What is 0.158655? What is that? The area under the curve. That's what it gave back to me, was the area under the curve, which is the same thing as the probability. I've forgotten already, you know I have. 0.1587. 0.1587, and I can, makes that look like a 2, doesn't it? And I can either put my probability as being 0.1587, or I could say 15.87%, right? Okay, is it making better? Getting clearer? Fantastic. So let's do 14. Again, 14 says yes. Vanessa. Yes. Yes. If I wanted this area, I would find this area and subtract. Or I can just even put them in my calculator now, which is nice. But that's going to be similar to 14, isn't it? Because 14, I'm going to take the same curve again. You're going to draw this IQ curve a whole lot. Okay, and again, I can put my normalized scores on there if I wanted to. Okay. Oh, I did. That's what I get for being in a hurry. Okay, so my problem says I want to find the probability, which we know is the area under the curve, for an IQ greater than 70. So for an IQ greater than 70, I'm going to come to 70 and I'm going to shade to the right because that's bigger. Okay? So what do you know? As soon as I shade this area, what comes to mind? Is the area going to be less than 50% or greater than 50%? Yeah, much greater than 50%. I can see that. I can see that. Okay? I'm finding area, probability, so I'm still going to use my calculator here, and I'm going to go second distribution. I'm going to cursor down to number 2, normal. What is my lowest limit? If lower means just like a number line, I'm going to go from left to right. -2. Can I put -2? Absolutely. Could I put 70 in? Absolutely. Yes, as long as I put in the correlating information. To standard or non-standard, I have to be consistent. Okay? So my lower, we can put in as 70, or we could put -2, either one. So what's my upper going to be? 9999999. I'm going to positive infinity. And because I use the non-standard scores, I'm going to leave mu at 100, and I'm going to leave my standard deviation at 15. Okay? And enter, and I get the answer back of 0.977249938. What is that? The area under the curve. The area under the curve. So that means this area, correct? I don't have to subtract from 1 or anything, do I? Because I put my lower being from here to the end. So that's the actual area it's giving me. My calculator can do that. Your table cannot do that. Okay, so I've lost it, 9,772. That is my probability.
And this is where you said that you might see a difference between
Yes.
different techniques.
Correct.
Just notice the difference between the two techniques.
Yes, there exactly. There can be some variance between if you're using that table or if you're using the calculator. I know there's going to be a little bit. I'll take either or. Exactly. Okay, so that means 0.9772 is my answer. Or 97.72%, right? Getting better, right? Okay, there's some more. Come back together and work on these problems. Make sure you got them right. Freeze my screen there. So in number 15, same thing, right? Same curve. Same non-normal scores. Standardized, I shouldn't say normal. Non-standardized scores. Okay. Matter of fact, I think I'm going to just go ahead. Oops. Can copy that. And again, because I know I've got 3 problems to do. not that one. I want this one. I'll just move them down out of our way. Okay. So on 15, we want to find the probability. Probability still means the same as what? Area. So I'm looking for area under the curve. That's another way to help remind yourself. A selected adult, excuse me, has an IQ between 90 and 110. Well, it's not so nice this time because it doesn't fall right on one of my normalized scores. Because I put my normalized scores on here again, 0, 1, 2, and 3, -1, 2, and -3. It's between 90 and 110, so I'm going to have something like here, closer to 100, sorry. And 110, right? That's where I'm at. I'm in between, aren't I? That's okay. Again, this is what I'm looking for. I'm looking for that area, correct? So I'm going to use my calculator, and because I don't have those normalized scores, I'm going to take the easy way out. And I'm going to go pull my calculator up and say second distribution. I'm going to cursor down, and since I'm finding an area, I'm going to cursor down to number 2, the normal curve. My lower limit is what? 90. My upper limit is 110. And I have my non-standard, so I'm going to leave them just like that. I'm going to cursor down. And I'm going to find it's 0.4950. And that is my probability. That is my area of this shaded region. 0.4950. So, or 49.5% of the population. That's half of us. That's half the population has an IQ between 90 and 110. Yeah. There, see? Number 16 says, though, that a randomly selected adult has a IQ. See, and that's the normal range right there, right? But an IQ between 110 and 120 is bright normal, is what they label that to be. So between 110 and 120. So let's go grab one of these that I've already copied. It just makes a little faster. And again, I could put my normalized scores. 110 to 120. About in there, right? Again, probability means area. Correct? Very similar to the last problem. I'm going to go ahead and bring up my calculator. And second distribution. My lower limit now is, my upper limit is 120. Cursoring on down, and the answer again it's going to give me is the area under the curve, which is the probability, which happens to be 0.161, and I'm going to round that to 3, 0.1613. Same thing as 16.13%. So about 16% of our population has an IQ between 110 and 120. Okay? Now this last one was one that might have stumped some of you a little bit more. I can go ahead and add my normalized scores. and it says find the IQ score where it's 90th percentile. Is that right? So 90th percentile. And I think it says separates. Yes. So I just want to point out for a second that 90th percentile is the same thing as separating the bottom 90 and the top 10%. That's the same, it's two different ways of saying the exact same thing. Last semester I had separating the bottom blah to the top blah, the most missed question. Okay? And that was a reading thing. Interpreting what it's saying. It's the same as 90th percentile. Separating the bottom 90 and the top 10%. Okay? I don't know where that's going to be. Is it going to be down here in this bottom half? See how it makes sense? Yeah, it's got to be up here, right? Got to be up here. So let's just do this. I don't know where exactly it's going to be. I may have to correct my drawing a little bit. That's okay. That might be a little high. I think that's going to be a little high. So what I've drawn here is what? Area. It's given me the area. It's given me 90th percentile. So can I do that? Does that mean the same thing? 90% is the same as 0.9000. And again, I like to constantly remind myself that is my area. So I always write 4 decimal places because it helps me remember. What am I looking for? The IQ score, correct? So since I have the area, I'm going to use inverse norm. My area has to be from the lowest level all the way up to here because that's the only way I can put it in. And of course I'm going to put in 0.900. If I leave mu at 0 and sigma at 1, I'm changing the Greek alphabet on you, sigma at 1, I'm going to get a normalized score. But I really want the IQ score, so I can put in my non-standard scores. I can put in that mu is 100 and the standard deviation is 15. The answer it gives me is going to be what? The IQ score, absolutely. And that IQ score is 119.2. Well, we know IQ scores are rounded to the nearest whole number, so I'm going to write it as 119. 119. Okay? That help? Okay. Good.